Welcome to Fun Facts Daily, your source for just the good stuff. Monday through Friday, we're bringing fun facts and news you can use, all carefully curated to uplift and inform. So give yourself a break, relax, and learn something awesome in just a few minutes every day. Hi everyone, I'm Kyle Wood, and today we're going to be learning all about microwaves. But before we get into the facts, let's warm up our brains with a little challenge to see if you can tell fact from fiction. Consider this. The magic of the microwave is that it can cook things in a fraction of the time it would take a traditional oven, but some say there's a cost to this convenience. You've likely heard warnings that microwaves emit harmful radiation that can damage human cells. Some say standing too close to a running microwave exposes your body to dangerous waves, and you should stand back while the microwave is on so you won't be cooked with your food. What do you think? Are microwave ovens really dangerous to be around? We'll find out at the end of the episode. Now for your word of the day. Our word for today is magnetron. That's M-A-G-N-E-T-R-O-N. A magnetron is a vacuum tube that generates microwaves using the interaction of a stream of electrons with a magnetic field. Inside a microwave oven, this device acts as the engine converting standard electrical current from the wall outlet into electromagnetic waves. These waves, operating at a frequency of 2.45 gigahertz, interact with water molecules in food to generate heat. Without a functioning magnetron, a microwave oven would just be a box with a spinning glass plate and a light bulb. The word magnetron combines the word magnet with the suffix tron, which denotes a device for manipulating subatomic particles. The physicist Albert Hull invented the first magnetron in 1920 while working at the General Electric Research Laboratory. Hull developed the device to serve as an amplifier in radio equipment, attempting to bypass patents held by other inventors. During World War II, British engineers John Randall and Harry Boot modified Hull's design to create the cavity magnetron, a smaller version that became a primary component in advanced radar systems. Time for your daily high five, our top 5 fun facts about microwaves. Number 1. A melted candy bar led to the invention of the microwave oven. In 1945, an engineer named Percy Spencer was working on active radar sets for the Raytheon Corporation. He stood near an operating magnetron and noticed a peanut cluster bar in his pocket began to melt. Spencer placed popcorn kernels near the magnetron, which promptly popped all over the laboratory floor. Then he placed an egg in a kettle near the device, and the internal pressure caused the egg to explode. After melting his candy bar, making a mess of popcorn, and blowing up an egg, Spencer naturally realized that microwaves could be brilliant for cooking food, and he filed a patent for a microwave cooking appliance later that year. The first commercial microwave oven, the Radar range, hit the market in 1947. It wasn't like the microwaves you might be used to today. It was about 6 feet tall, weighed over 750 pounds, and cost $5,000. It utilized a water cooling system to manage the heat generated by the magnetron. Because of the size and cost, early microwave ovens were primarily purchased by restaurants, railways, and cruise ships. The first domestic microwave for home use didn't become available until 1955, and it took another decade for prices to drop enough for it to be really widespread in people's homes. Number 2. Microwaves target water molecules to generate heat. The electromagnetic waves in a microwave oven have a frequency that interacts primarily with water, fats, and sugars. Water molecules are dipoles, meaning they have a positive charge on one end and a negative charge at the other. As the microwaves pass through the food, the electromagnetic field alternates its polarity billions of times per second. The water molecules rotate back and forth in an attempt to align themselves with the shifting field. This continuous rotation generates friction between the molecules. And this molecular friction creates the thermal energy or heat that actually cooks the food. It's all about the movement of the water molecules, and that's why a dry paper towel will stay cold in the microwave while a damp paper towel will begin to steam in a few seconds. It also explains why ice is difficult to melt in a microwave. The water molecules in the ice are actually locked in a crystalline structure that can't rotate so freely. And materials that don't have water, like glass, ceramics, and most plastics, don't absorb microwave energy. They'll remain cool. And some of you might be thinking you've picked up bowls from the microwave and they're anything but cool. That's true, but the microwave isn't directly heating like a ceramic bowl. The containers become hot because of conduction, as the food transfers its heat to the dishware. And here's a little bonus fact for today. While people often say that microwaves cook the food from the middle out, that's really not the case. Because of how the waves interact with matter, microwaves only penetrate the food at a depth of about 1 to 1.5 inches. The radio waves heat the outer layers of the food by agitating the water molecules near the surface. The heat generated in these outer layers then travels to the center of the food through standard thermal conduction. And that's why you can have a frozen meal that stays ice cold in the middle and gets burned on the outside. If you want to avoid that, it's best to try to, cut things up a little bit or take sort of a donut approach and hollow out the middle so that the microwave radiation can better penetrate the meal all around. Number 3, grapes create plasma fireballs when they're placed in the microwave. Now, first off, I should say never do this, but if you place a sliced grape into a microwave, it will generate a glowing fireball of plasma. For decades, physicists believed this occurred because the grape halves acted like an antenna conducting electricity across the thin skin connecting them. In 2019, researchers at Trent University published a study proving that the grape is actually acting as a dielectric resonator, not antennas. The spherical shape and high water content of the grape halves trap the microwaves, causing the electromagnetic energy to resonate and build up in the center. When the two grape halves sit close together, their electromagnetic fields interact and amplify at the point of contact. This concentrated energy strips electrons from the sodium and potassium ions in the grape skin, ionizing the surrounding air. The ionized gas ignites into a small orb of glowing plasma that will scorch the interior of the appliance. Scientists have replicated the same phenomenon using hydrogel beads and quail eggs, so it's more about the geometry and water content rather than the specific chemical makeup of a grape. And on the topic of things that we should never put in the microwave, we've all heard you shouldn't put metal in the microwave. Well, here's why. Metal sparks in a microwave because it's a highly conductive material that forces electric charges to build up rapidly on the surface. When a metal object with sharp edges, points, or creases like a fork or crumpled aluminum foil, when you put that stuff in the microwave, the electrons bunch up at these narrow points, ionizing the surrounding air and creating sparks in a phenomenon called arcing. Number 4. Scientists have found you can actually use microwaves to take care of weeds in a field. Agricultural researchers have developed tractor-mounted microwave arrays to eliminate weeds without using chemical herbicides. These machines direct high-intensity microwave radiation into the soil as the tractor drives over crop rows. The electromagnetic energy heats the water inside the weed stems and root systems until the plant cells rupture. This thermal shock destroys the weeds instantly, preventing them from competing with cultivated crops for soil nutrients and sunlight. This technology offers a solution for farmers dealing with herbicide resistant weed species. And more importantly, traditional chemical sprays can drift into the wind or run off into local water supplies, causing other environmental issues. The microwave weed control method leaves no chemical residue and targets only the plants located directly beneath the transmitter. And our fifth and final fun fact for today: the universe has a background glow of microwave radiation left over from the Big Bang. In 1964, astronomers Arno Penzias and Robert Wilson discovered a constant background noise while calibrating a radio antenna in New Jersey. They initially thought the interference came from urban radio broadcasts or pigeons nesting inside the antenna structure. After ruling out all the earthly sources they could think of, they realized this uniform signal was actually coming from all directions in space. This signal, known as cosmic microwave background, is the residual thermal radiation from the universe's initial expansion about 13.8 billion years ago. The cosmic microwave background provides scientists with a map of the early universe. As the universe expanded, the intense light from the Big Bang stretched into longer, lower energy wavelengths, eventually falling into the microwave region of the electromagnetic spectrum. Before modern digital television, analog TVs would display visual static when tuned between stations. About 1% of that static was actually caused by the antenna picking up ancient microwaves traveling through the cosmos. Now for some news you can use. You can actually use your microwave for more than just cooking. It can be a great cleaning tool. You can eliminate bacterial colonies from a kitchen sponge by using your microwave oven. Just soak a sponge in water and put it on a microwave-safe plate. Heat the sponge on high for about 1 or 2 minutes. Be sure to let the sponge cool before you pick it up. You don't want to burn yourself on a scalding sponge. The microwave energy brings the water inside the sponge to a boil, generating steam that permeates the material. Researchers have found that this method will kill over 99% of bacteria, yeast, and mold present in the sponge. That thermal energy denatures the proteins in the bacterial cells, destroying their structure and preventing them from coming back. Just be careful to make sure the sponge is wet before it goes into the microwave. A dry sponge could actually be a fire hazard. And you can also use a similar steam-based approach to clean the interior walls of the microwave itself. Just fill a microwave-safe bowl with 2 cups of water and 2 tablespoons of white vinegar. Heat the mixture on high for about 5 minutes until the liquid boils and fills the entire space with heavy steam. Keep the door closed for about 3 to 5 minutes to trap that moisture inside. The boiling liquid turns into water vapor and condenses on the interior ceiling and walls. This concentrated steam softens dried food splatters and loosens grease bonds on the plastic and metal surfaces. The acetic acid in the vinegar acts as a mild solvent to cut through lipid layers while neutralizing food odors. After that steam treatment finishes, you can easily wipe everything clean using just a damp cloth or your freshly cleaned sponge. Finally, the moment you've been waiting for. At the beginning of the episode, I asked, do microwaves really emit harmful radiation? Well, this one's a fallacy. While microwaves do use radiation, it is non-ionizing radiation, meaning it doesn't have the energy necessary to knock electrons out of atoms or damage human DNA. Also, the metal mesh screen built into the glass door reflects the waves back into the cooking chamber, keeping the radiation safely contained within the device. As long as the door hinges and latch aren't damaged, there's really no health risk associated with standing next to a running microwave. It's not going to affect your cells or your body more broadly. Now, I hope you enjoyed learning a bit about microwaves with me today, and be sure to tune in every weekday for even more fun facts. Fun Facts Daily is an Airwave Media podcast. It was written, recorded, mixed, and edited by me, Kyle Wood. Thanks for sharing a part of your day with me. Be sure to follow Fun Facts Daily on your favorite podcast app so you can keep the good stuff coming your way every day. And if you like the show, please do me a favor and leave a kind rating, review, or just tell your friends about it.